Good day, class. Today we will talk about our new topic, which is rational numbers. First, how will you define rational numbers? So, rational numbers are numbers which can be expressed in the form a over b, where a and b are integers and b should not be equal to 0. Because when the denominator is equal to 0, that is not rational numbers. Okay, take note that the denominator should not be equal to 0. Example of rational numbers. So we have 1 half, 3/4, 4 over 5, 1, 2, and any number that can express as fraction. So another example, we have decimal numbers. We have 0.5, that is 1 half in fraction, 0.75, that is 3/4 in fraction, and so on and so forth. Any number that can express as fraction will call as rational numbers. So let's have this activity. Using the number line below, approximate the rational numbers denoted by letters above each point. So given the number line with point named by its letters, so let's approximate or estimate the value on that point. For you to answer that, you can pause this video. Now, I will show you my approximated value of that given points. So for me, point H is approximately negative 3.6 because that is more than halfway between negative 3 and negative 4. So I must say that our point H is negative 3.6 or negative 3 and 3 over 5 in fraction. So point I is less than halfway between negative 1 and negative 2. So I must say that it is approximately negative 1.3 or negative 1 and 3 over 10. My point J is approximately 0.75 or 3/4 in fraction because as you can see, point J is more than halfway between 0 and 1. That's why I must say that point J is 0.75. Then point K is approximately halfway between 1 and 2. So I approximate it as 1.5 or 1.5 in fraction. Then point L, that is more than halfway between 2 and 3. So I must say that point L is approximately 2.75 or 2 and 3/4 in fraction. Then my point M is 3.3 or 3 and 3 over 10 because that is less than halfway between 3 and 4. Okay, then my point N is, so as you can see, less than the halfway between 4 and 5. So my approximated value is 4.3 or 4 and 3 over 10 as the value of point N. So what I'm showing you is that we can write the rational number as, or we can express the rational number as decimal number or in fraction form. So because today we're going to deal with converting fractions to decimals and decimals to fractions. So first, let's have converting fractions to decimals. How to convert fractions to decimals? So take note that to convert fractions to decimals, you have to divide the numerator by the denominator. Okay, example. So we have three examples. We have number 1, 2 over 5, number 2, 17 over 3, and number 3, 5 and 2 over 9. Take note that repeated digit may be written with bar on top of the repeated digit or digits called repeated. Okay, so on the latter part, you are able to know about this note. Okay, let's have the examples. Number 1, 2 over 5. As I can say, or should I say, as I said, we have to divide the numerator by the denominator. So here we have 2 over 5. Therefore, we have to divide this 2 by 5. So we are unable to divide 2 by 5. Therefore, we have to add 0 here. So that is 0.0. Take note, if you have here the decimal point, therefore we will add also decimal point on the quotient. So suppose we have to add 0. Now we have 20. Just ignore the decimal at this moment. So we have 20 divide 5, that is 4. Okay? So because 4 times 5 is 20. Now we have to subtract 20 by 20. 20 minus 20 is 0. So we don't have any value. Our answer will be 0.4. So take note that this decimal point should be aligned. Okay, aligned. That is 0.4. Our answer for number 1 is 0.4. How about number 2? 17 over 3. Okay, so we have to divide 17 by 3. So we are able to divide 17 by 3, that is 5, because 5 times 3 is 15. Now we have 17 minus 15 is 2. Then, now we are unable to divide this 2 by 3. We will add 0 as we did on number 1. So that will become 0, bring down 0, that is 20. Then 20 divided 3 is 6. Okay, because 6 times 3 is 18. Now you have to subtract 20 by 18, that is 2. So, again, if you add here another 0, that will become 20. Then you have to divide 20 by 3, that is 6. Again, 6 times 3, 18. So that is continuous. Therefore, I must say, or we can say that this will be 5.6666 and so on and so forth. So our answer, or the conversion of 17 over 3 in decimal number is 5.6. Okay, 17 over 3 in decimal number is 5.6 in decimal form. So how about number 3? 5 and 2 over 9. So as you can see, we have here the whole number 5. So we will write here 5. Then you will be adding that 5 to the quotient. Okay, whatever the quotient is. Now we have to divide the numerator 2 by 9. So we have 2 divide 9. We are unable to divide 2 by 9. We will add 0, same process as we did on the previous 2 examples. We add 0, that is, or the number will become 20. So 20 divide 9 is 2. 2 times 9 is 18. Now subtract 20 minus 18 is 2. So again, if we add 0, that will become 20. we are going to divide it by 9, that is 2, because 2 times 9 is 18. As you can see, continuous process. Therefore, you have to stop there because our answer is 0.22222 and so on and so forth. So our value in decimal form of 5 and 2 over 9 is 5 plus 0.2222 is, that is 5.2 with vinculum. So I forgot to tell you that this bar at the top of 6 is vinculum, which means that that number 6 or that digit is a repeating digit, as well as this. So 2 is repeating digit. So this 5.2 with bar at the top of 2 means 5.22222 and so on and so forth. So next, so more examples. As you can see, fraction 1/2, we will divide it using the division or long division, that is 0.5 in decimal. 11 over 20, we will use long division. Okay, you can pause it for you to review the process. Then, that is 0.55 in decimal form. 1/3 long division, then 0.3333 and so on and so forth, because we have here vinculum, which means that 3 is being repeated, or the repeating digit. Now it's your turn. Try to solve or convert the following fractions into decimal form. So we have number 1, 10 over 9. Number 2, 8 over 11. Number 3, 3/4. And number 4, 25 over 6. So you can pause this video so that you are able to answer the following. Now I will reveal the answer. So the correct answer will be, okay, number 1, just check your answers. Number 1 is 1.11 and so on and so forth, or 1.11 with vinculum, or 1.1 with vinculum at the top of 1 after decimal point. Then number 2, 0.7272 ... or 0.72 with vinculum, because it means that 72 is being repeated. Then number 3 is 0.75. The number 4 is 1.5625, or 1.5625 ten thousandths. Okay, so just check your answer. Next, we have converting decimals to fractions. So in converting decimals to fractions, you have to take note of this. We have the kinds of decimals. First, we have the terminating decimals. When we say terminating decimals, those are decimal numbers having an exact value. So we have the definite value of a decimal number. So examples, we have 0.4, 0.125. This 0.4 can also called as 4 tenths, because its place value is tenths. Then this will be 125 thousandths, because we have tenths, hundreds, thousands. So we have thousandths as the place value. So 125 thousandths. We also have 5 tenths, 75 hundredths, and so on and so forth. So exact value, no repeating. Okay? Then number 2 is repeating decimals. So here we have, or you are able to encounter repeating digits, that is repeating decimals. So those are decimal number or numbers having a digit that repeats indefinitely. So infinitely repeated. Examples, we have 0.333 or 0.3 with bar at the top, then 0.8333 or 0.83 with bar at the top. So as you can see, those three dots are called ellipses. So it means that the digit before it is being repeated. Then the bar at the top is called, as I said earlier, we have vinculum. It means that the digit below it is being repeated, or that is the repeating digit. So as I said earlier, we can say that the digit is repeated. So here in 0.333, the repeated is 3. Then here, the repeated is, I'm sorry, that is only 3. Okay? So the repeated here is 3 also in 0.833. Okay? It should be 0.83 with vinculum at the top of the digit 3. Then let's have the examples. Converting decimals to fractions, case number 1. So if our given is the terminating decimals, so that is exact value. Example, we have 0.3 or 3 tenths. Okay, take note that its place value is tenths. So that is tenths. To convert it into decimal, you have to take note that get the given decimal number and make it as your numerator. Then the place value will be your denominator. Therefore, we have 3, that is our numerator, then place value tenths. So our denominator is 10. Therefore, our fraction is 3 over 10. Okay? 0.3 is 3 over 10 in fraction. Number 2, 0.45 or 45 hundredths. As you can see, 45 hundredths. Therefore, its fraction form will be 45, our numerator, then place value denominator, hundredths, that is 100. Okay? So 45 over 100, as you can see, that is big number or fraction. Take note that you have to reduce it to lowest term if possible. So don't forget to reduce in lowest term. So what will be the common factor of 45 and 100? That is 5. Okay, so we're able to divide 5 to this numerator and denominator. So 45 divide 5 is 9 and 100 divide 5 is 20. Therefore, 0.45 or 45 hundredths is 9 over 20 in fraction. So how about this case number 2? What if the given is the repeating decimals that contains repeating digit only? So we have a repeating digit as our given. Examples, we have 0.666666 and so on and so forth. So what are you going to do is to take the repeating digit. So what is the repeating digit? We have 6. Take that as your numerator. So 6. What will be your denominator? Take note that the denominator will be the number, will be 9. But the number of 9 should be or should depend on the number of digits or repeating digits. How many repeating digits or digit? So we only have one repeating digit, that is 6. Therefore, our number of 9 in the denominator is 1 also. So we have 6 over 9. So what will be its lowest term? We are able to divide 6 and 9 by 3. So we have 6 divide 3, 2, 9 divide 3 is 3. So the fraction form of 0.66666 and so on and so forth is 2/3. How about 0.45? As you can see, the vinculum is above 45. So the repeating digits are 45. That will be our numerator. How many repeating digits? We have 2. Therefore, the number of 9 is, or we have 2 nines. That is 99. Okay? So 45 over 99. Now, let's reduce it into its lowest term or simplest form. So 45 and 99 is divisible by 9. So 45 divide 9 is 5 and 99 divide 9 is 11. So 0.45 with vinculum is 5 over 11 in fraction form. Okay, now we have the case number 3. When the decimal number is a repeating decimal and it contains non-repeating digit. So we have repeating decimals, but there is non-repeating digit. Example, we have 0.27 with vinculum at the top of 7 or above 7. Therefore, the repeating digit there is 7 and the non-repeating digit is 2. Okay? So, to convert it into fractions or fraction, first you have to get the given number or decimal number and take it as whole number. So we have 27. Then subtract it by the non-repeating digit. Okay? As you can see, 27. What is the non-repeating digit? 2. So 27 minus 2 is 25. Now, the result will be your numerator. Okay, we have 25 as the numerator. Now, what will be our denominator? Take note that the denominator will be the number or will depend on the number of repeating and non-repeating digits. So, how many repeating digits? Okay, so there is only one repeating digit. That is 7. So we have 9 or only 1 9 in the denominator. And when we have the non-repeating digit, we have 0 at the denominator. Therefore, since we only have one non-repeating digit, we also have 1 0 in the denominator. So you will write 0 after 9. Therefore, our denominator is 90. Okay, so 25 over 90. Don't forget to reduce it in lowest term. That is, the common factor is 5. We are able to divide 25 by 5 and 90 by 5. So 25 divide 5 is 5 and 90 divide 5 is 18. Next example, 0.1245 10,000s, wherein, as you can see, we have vinculum at above 45. Therefore, that number or that digit is repeating digit. Okay, so take it as whole number, 1245. subtract it by the non-repeating digit. So 1245 minus 12 is 1233. That will be our numerator. Now what will be our denominator? We have two repeating digit, that is 45, and two non-repeating digits. Therefore, the number of 9 is 2 and the number of 0 is also 2. Our denominator will be 9900 or 9900. Now, don't forget to reduce it in lowest term. So the common factor will be 9. We're able to divide 1233 by 9, that is 137. Then 990 divide 9 is 1100. Therefore, the fraction form of 0.12454545 and so on and so forth is 137 over 1100. So, check if each rational number in fraction form is correctly expressed in decimal form and vice versa. If not, provide the correct answer. So number 1, 4 over 5 is 0.80 in decimal form. The number 2, negative 33 over 50 is negative 0.66 or negative 66 hundredths. Then negative 2/3 is positive 66 hundredths. Then 0.5 with vinculum is 4 over 7 in fraction. Negative 1.34 is negative 33 over 250 in fraction. 3.44 is 43 over 125 in fraction. What do you think? You can pause this video to have your answer. Okay, now I will reveal the answer. For number 1, we have, okay, that is correct. So because 4 over 5 is 0.80 in decimal number, you have to divide 4 by 5. You will get 0.80 or 0.8. Number 2, that is also correct. Okay, if you divide 33 by 50, you will get 0.66 and the sign will be negative because we have here negative fraction. Then number 3 will be, it should be negative 0.66 and so on and so forth. Okay, because when you divide 2 by 3, you will get this value, okay, instead of this one. Number 4, 0.5 with vinculum is, that should be 5 over 9 in fraction, okay? Because as you can see, 5 is repeating digit, therefore get this 5 and take it as your numerator. Then how many repeating digit? 1. Therefore, the number of 9 in the denominator is 1, so 5 over 9. Now we have number 5. It should be negative 1 and 17 over 50. Okay, so take note, as you can see, the denominator here is 250, wherein here, our placed value in the decimal number is hundredths only. Therefore, it should be 100. So it's not possible that the denominator is 250. The correct answer will be this one. The number 6, we have 3 and 11 over 25. So same goes with number 5. The denominator is 125, wherein the placed value of the given decimal number is hundredths only. Therefore, it should be 100. Okay, so 44 over 100 divisible by 4, that is 11 over 25, or we have the whole number 3, 3 and 11 over 25. To sum it up, we have these questions. How to convert fractions to decimals? Okay, to convert fractions to decimals, you have to divide the numerator by the denominator. How to convert the following to fractions? Case number 1. If the given is terminating decimals, first you have to use the given decimal number as numerator. So you will get the given decimal number, then make it your numerator. Then use the place value as the denominator. Example, a while ago, like the example a while ago, we have 0.3 or 3/10. We will get the given decimal 3, then place value over 10. Same goes with 0.45 or 45 hundredths. Numerator is 45 and denominator is 100. So 45 over 100 is 9 over 20 in lowest term. Then, how to convert the following to fractions? Case number 2, repeating decimals that contains repeating digit only. We have used the repeating digit as the numerator. So, you will get that repeating digit, then make it your numerator. Then the denominator will be 9. Take note that the number of 9 will depend on the number of repeated digits. So, like the example a while ago, we have 0.6666. The repeated digit is 6. That will be your numerator. Then how many repeated digit? That is 1. So, only 1 9. 6 over 9 is 2/3 in lowest term. So, same goes with 0.45 with vinculum. We have 45 over 99. And that is 5 over 11 in lowest term. Case number 3, we have when the decimal number is repeating decimal and it contains non-repeating digit. So first, you have to take the whole number, or taking as whole number, subtract the non-repeated digit from the given decimal number. Okay, so you have to take that decimal number as whole number. So like a while ago, we have 0.1245. We will take 1245 instead of 0.1245. Then we will subtract the non-repeated digit. So we will subtract 12 by 0.1245. Then the result is your numerator, that is 1233. Then the denominator will be 9 and 0. That is always when the given is repeating and then repeating digits. So the number of 9s depends on the number of repeated digits. And the number of zeros depends on the number of non-repeated digits or digit. So, class, don't forget to answer the activity in VSmart. That is the part A and part B. Converting fractions to decimals and converting decimals to fractions. That would be all, and God bless us all.